whereby D in the lower level goes to what? Higher level. Remember that, as you can see there on the screen, this is the configuration showing you the S block, the P block, and the D block. 3D9. This is incorrect. So the correct thing should be what? 1s2, 2s2, 2p6, 3s2. So under this magnetism, there are different forms of magnetism that transition metals can exhibit. They can exhibit dimagnetism, paramagnetism, ferromagnetism, ferrimagnetism, possibly antiferromagnetism, depending on some factors, environmental factors, including temperature. The color you see from any substance is the color reflected by that substance. Those ones you don't see are the color absorbed. We have 7 colors. In this video, I will be demystifying the fascinating topic, transition metals. Here are what I'll be discussing. Number 1, the origin and the meaning behind the term transition metals. Number 2, a comprehensive definition of transition metals. Number 3, easy mnemonics to help you master the 3 transition series. Number 4, insights into the unusual nature and electronic configuration of the transition metals. Number 5, intriguing facts about the transition metals. Number 6, identification of the non-transition members within the D block and why they are exceptions. Number 7, general characteristics of transition metals, including catalytic activities, variable oxidation state, formation of complex ion, paramagnetism, and more. Enjoy watching and feel free to drop your question in the comments section below. If you find this video helpful, don't forget to like, share, and subscribe for more engaging content like this. Much love from me to you. Let's take an exciting journey through the chemistry of transition metals together. I promise you, you will love it. Let's go. Transition metals. Your understanding of this topic, transition metals, you are advised to watch my introductory video on metals. Revisiting electronic configuration and the periodic table will catalyze your comprehension of this topic. Now, what are transition metals? What are transition metals? These are elements in the D block of the periodic table whose atoms have partially filled D orbitals. Repeat, partially filled D what? Orbital. The major thing there is partially filled D orbital, or which can give rise to what? Cations with incomplete D subshell. This definition is gotten from the old edition of the IUPAC Gold Book. Defined like this in exams, but under IUPAC recommendations, where the groups are numbered from 1 to 18, unlike the common 8 main groups you are used to, that is, the 2011 IUPAC Principle of Chemistry of Chemical Nomenclature described a transition metal as any element in groups 3 to 12 on the periodic table. This implies that there are 10 transition groups. Why the term transition metals? Literally, transition means changing or passing from one phase to another, or from one place to another, or going across from one end to another. In fact, the word transition comes from the Latin words transire or transitio, which means to go across or a going across. The term transition can be applied when there is a noticeable change in existing scenario. Over here in Nigeria and some other parts of Africa, you often see people replace the word obituary with transition to glory while announcing person's death. This is mainly due to the belief that death is not the end, but a passageway to change from life to afterlife or spiritual realm. Charles Rugglesberry, an English chemist, was the first to use the term transition metals in 1921 to describe the series of elements on the periodic table that were changing between stable electronic configuration in their inner shells, mainly those that occur from the 4th row, period 4, that's period 4, that transition from stable group of 8 to a stable group of 18 electrons in their penultimate shell. That is N equals 3, that is M That's M share for period 4. In this case, extra 10 electrons are added gradually and successively to the n-1 share to increase the number from 8 to 18 for elements in the D block. Electrons are successively added to the penultimate share, that is the second to the last share. This is unlike the S and P block elements, where electrons are successively added to the last share as you move across the period. This transition also occurs from 18 to 32, where extra 14 electrons are added gradually successively across the period in n-1 share for the elements in the F block. And here is the principal quantum number of the last share. Hold on. Looking at this majestic periodic table you can see behind me, we will see that there are 4 blocks in the periodic table according to the 4 subshells S, P, D, and F. Out of which 3 blocks, S, P, and D blocks are